In this video, I will talk about the equipotential line. As the name suggests, equ means the same and the potential means the potential. That means the same potential contour or line are called the equipotential line. Let me explain this one. Let's say you have a positive charge and a negative charge. So these lines tells you the direction of the electric field. Okay, so this tells you the direction of the electric field. So what is the what does this mean? That means if you put a test positive charge, it will move in this direction. If I move one test positive charge here, one tiny test positive charge, it will move along the tangent at this point. If I move a test positive charge, it will move along the tangent at this point. So this is the direction of the electric field. Okay, and this line here, this line, the closed line, this closed line are the equipotential. That means it doesn't matter where you measure at this point or this point, it does have the same potential due to the positive and due to the negative charge. So this entire closed line is the equipotential line. This, and one thing I would like you to point it out, this and this are the different potential, but this one closed loop is at the same potential. This one closed loop is at the same potential, but this closed loop and this closed loop might be at the different potential. Okay, so if you need to find out, if you have, let's say, charged particle, and if you move from one point here to this point on the same contour line, then no work is required. So if you move along the same equipotential line, then no work is required. Why is that? If you remember, the work done is equal to Q times the change in the potential. Okay, the work done is Q times the delta V. The delta V is the change in the potential. If this potential difference is 0, that means if it is on the equipotential line, then no work is required. Okay, so it doesn't require any work to move onto the same potential. This is just like, let's say, if you compare it in terms of the gravitational field, what does that mean? Let's say this is the ground level, this is a ground, okay, and you have a charge part, or you have a mass here, and this height is h. If you move this mass along this height, let's say from point A to point B, and it is at the same height, then no work is required, because there is no change in the potential energy. The potential energy at this point is still mgh, and the potential energy at this point is still mgh. So there is no change in the potential energy. If there is no change in the potential energy, then there is no work done, because it is a conservative system. Okay, so again, now this is due to the positive and negative charge. Now if you have positive and negative charge, let's say, for example, in this case here, again, this one represents the direction of the electric field. And as you see, as this is a negative charge, the electric field is always towards the negative charge. But if you have a positive charge, electric field is always away from the positive charge, and the electric field is towards the negative charge. Okay, all the electric fields now try to terminate onto the negative charge. So this is the direction of the electric field, and the two electric field lines never cross each other. And this closed loop here are the equipotential line, which is given right here. These lines, or this line are the equipotential line. As you see now here, this one is at negative of 10 volt, and this is negative of 5 volt. This is at negative of 2 volt here. So this, anywhere, if you measure the electric potential at any point on this line, you'll get negative 10 volt. If you measure anywhere onto this dumbbell, then you will get minus 5 volt. If you measure anywhere on this ellipse, you'll get negative 2 volt. So this is the equipotential line. What the significance about the equipotential line? That means if you have to move a charge from point A, let's say from point A to point B on the same equipotential line, then you do not need any work. No work is required to move a charged particle on the same equipotential line. Okay, let me try to give you a little more intuition on this one. Here I have some simulation. So let's say you have one positive charge and then one negative charge here. If you try to measure the equipotential line, what you do here, just bring it here and then create an equipotential line. Now here I'm creating the different equipotential line due to, so I can create many equipotential line here. Oops, I think I deleted this one. So this all the contour, all the closed loops are the equipotential line due to the positive and negative charges. Okay, that means if I measure the potential, electric potential, now see at this point it is minus 5.53 volt. If I measure at any point onto this line, it should get exactly the same value. Any point on this closed contour, it will give exactly the same value. That's why it is called the equipotential line. And now even here, if I measure, this one is negative because it is closer to the negative charge, and this one is positive. And again, if I measure at any point, still it's the same value. That's why it is called the equipotential lines.